Howdy Rock Buds, it's Rock Papa. Hope you guys are doing well. It's really hot here at the Minimalist Cottage. I would say hotter than a French frog leg in a frying pan, but we're carrying on. Today's rock story is Biotite GNEISS. We're going to learn what it is, what it's made of, and where it comes from, and what it had to do with the formation of the eastern United States. So stay tuned, and if you like this video, please subscribe. Thank you so very much to everyone who has subscribed. I appreciate that immensely. Here we go. Rock story, Biotite GNEISS. Biotite GNEISS is a metamorphic intermediate rock. Metamorphic means that the original rock was deeply buried, subjected to intense heat and pressure, and that turned it into a metamorphic rock called Biotite GNEISS. Biotite GNEISS is an intermediate reaction rock. That means it's in between felsic rocks that are quartz-rich and mafic rocks that are quartz-poor and iron and magnesium-rich. Here's some pictures of Biotite GNEISS for your viewing enjoyment. Do you notice the kind of salt and pepper speckly look of Biotite GNEISS? If this were granite, you would see mostly light colors because granite's a felsic rock. If this was basalt or amphibolite, which are mafic rocks, you'd see mostly dark black. You would see some white, but you'd see a lot of dark black. Biotite GNEISS is made of the minerals sodium-rich feldspar, biotite mica, and quartz. In this example of Biotite GNEISS, you can see white or yellowish crystals. Those are the sodium-rich feldspar. How do we know this is mostly sodium-rich feldspar? Because sodium-rich feldspar is an intermediate reaction feldspar, and you find it in intermediate reaction rocks. What do you think the black spots in this rock are? You got it, mostly biotite mica, and you may be able to see some grayish or clearish mineral crystal spots, and that would be quartz. By the way, one of the ways that we can recognize this as a metamorphic rock is the metamorphic banding, which separates the minerals into light and dark stripes. Hey guys, if we find a salt and pepper rock and we think it's Biotite GNEISS, how do we test that black mineral to see if it really is biotite? Let's find out. Here's a salt and pepper rock, and we want to know if the black stuff here is biotite, and that would make this Biotite GNEISS. So we take a nickel coin, which we know can scratch biotite, and we scratch the heck out of the top of the rock and the side of the rock, and we look for a gray dust. Then we try to wipe that gray dust off. If we wipe the gray dust off and the scratch stays, then we're pretty sure this is biotite. And as a last resort, we can always look for the initials BG on the rock, which stands for Biotite GNEISS. They come like that in nature. Now let's look at a mafic rock. This is basalt. It has no biotite in it. Instead, it has the dark mineral pyroxene, which a nickel cannot scratch. Let's give it a try. No gray dust, no scratch. Keep trying. No scratch, so we definitely have a mafic rock, and we know the mineral is likely to be pyroxene. So what is the protolith of Biotite GNEISS? Protolith means what igneous or sedimentary rock was metamorphosed and became Biotite GNEISS. A logical way to figure this out is to look for an intermediate reaction igneous rock or sedimentary rock. And when we do that, we find diorite, an igneous intermediate intrusive rock, and its above ground equivalent, andesite. When diorite magma erupts onto the surface, it becomes andesite lava, and andesite lava can look several different ways, and here are some of those ways. And so, most excellent rock buds, how does diorite magma and andesite lava turn into biotite gneiss? Let's find out. This side view picture shows black ocean crust, which is on the right, being subducted beneath a continent and forming a volcanic island chain. A lot of ocean water is going down with the subducted ocean crust, and this gives rise to fractional melting. Fractional melting can produce three kinds of magma. At the top, the white color is very felsic magma, and at the bottom, the black color is very mafic magma, and in the middle, the salt and pepper color is, you guessed it, intermediate magma, and it is diorite magma. And when it erupts onto the surface of the volcano, it becomes andesite lava. Hey rock buds, this volcanic island, which was created, and it's actually a volcanic island chain, will eventually be smashed into the continent, and in that process, those rocks will be buried and subjected to high temperatures and pressure, and the intermediate diorite and andesite will very likely become biotite gneiss. Let's go looking for some biotite gneiss. Here's a Rock D geology map of Georgia. The red arrow points to the Brevard Fault Zone that separates the eastern Blue Ridge Province to the northwest from the inner Piedmont Province to the southeast. And we are checking out the rocks where the blue circle is, and that would be in the inner Piedmont geologic terrain. When we push on this area, Rock D tells us this is made of biotite gneiss, mica schist, and amphibolite. And our inner Piedmont terrain has loads and loads of these three rocks. These are the metamorphosed remains of a volcanic island chain. Biotite gneiss could very likely be diorite and andesite. The mica schist could be tuff blown out of a volcano and flushed with hydrothermal fluids from the volcano. And the amphibolite could be gabbro, pluton, and or basalt lava. This volcanic island arc terrain runs all the way up the eastern United States from Alabama up to New York and even further north perhaps. And it's loaded with biotite gneiss. Okay, most excellent rock buds, that's the story of biotite gneiss. Thank you so much for watching. And this is your Rock Papa saying, happy rock hunting to all you guys.